Hello, welcome back to another video, and as promised, here I am with the Python video of the Mersenne primes and perfect numbers. So let's get into it. Okay, so well, we are on my Python page, and now let's get into it. So now first, let us define a function which checks if a number is prime or not. And now for this we don't have to import any library, so let's just get into it. So well, I'll just comment it out. I'll just comment it because well, it's easy to maintain stuff, comment stuff. So check if a number n is a prime number. Now let's define a function is prime n. Okay, now well, we'll just put the basic things. If n equal to 1, then return 0, which means it is not a prime, right? And now let's get into it. So let's put a for loop, and for I in range 2 to n by 2, if n, well, now why did I put the range as 2 and n integer divided by 2? Well, practically just because 2 is the smallest prime number. Now if I start the range with 1, all numbers are divisible by 1, right? So now I started with 2, and now that seems reasonable that I started with 2, but why did I end with n integer division by 2? Well, that's basically because if a number, well, how do I explain this? A number cannot be divisible by a number greater than half of it, because, well, now if you remember, I showed you all the factors of a number, and you might notice that how they were symmetrical, right? The smallest factor of a number is 1, and the largest factor of a number is number itself. If the second smallest factor is 2, then the second largest factor will be n divided by 2, right? So that's basically it. And I'm trying not to include n because I want to see if a number is prime, right? So I'm basically taking all the factors except n. So I'm taking the second largest, and there you have it, why I took an integer division by 2. So n remainder with I is equal to 0. This percentage is a notation for remainder, like the remainder if you divide n with I. Basically if I divides n or not. So if there's any I in that range which divides n, then that is not a prime number. And if basically you go through all the i's and you find out that nothing divides n, then well, obviously that is a prime number. Now we can definitely test it out. Print is underscore prime of, well, let's just take 2, run, and as you can see over here, well, I'll get this a bit bigger, it returns 1, which means that 2 is a prime number. Let's take with 3, it's a prime number. Let's go a bit deeper. 25 is not a prime number. Let's take 47 is a prime number. Okay, so it is working. Now what is the next step? Well, the next step is to see if a Mersenne number is a Mersenne prime number. So well, checks if 2 to the power n minus 1 is a prime number. Well, from now on, let's just call this number the nth Mersenne number, or let's just say n is the Mersenne index of 2 to the power n minus 1. It'll just make it easier. Okay, so def is underscore Mersenne underscore prime n. Well, if n equal to 2, return 1. Well, I just like to put these initial conditions first, because if you have trivial conditions, it just reduces time, right? Just looking at one small if loop, or going into another function and testing it out all over again. It's just easier. And so with this way, if I do n, if n %2 is equal to 0, return 0. So basically these two were basically just me saying that if n is an even number greater than 2, it cannot be a Mersenne prime, which I have already derived in my video on Mersenne primes. So this basically reduces all our computation if n is an even number. So now let's get into the other numbers. So if is underscore prime, because we already have this function which tests if a number is prime or not, we can directly go to that function. So if underscore prime 2 to the power n minus 1. So if 2 to the power n minus 1, or if the nth Mersenne number is a prime number, it is a Mersenne prime. So at that time we return 1, and if that number is not a prime number, we return 0. Okay, so now we know if a number is a Mersenne number or not, is a Mersenne prime or not. Now let's give a function to find perfect numbers. So now we have to find a function which returns the perfect number up until a Mersenne index n. Okay, so basically go from all numbers from 0 to n and see and find all the Mersenne prime numbers, and it will return perfect numbers corresponding to that Mersenne number. Okay, so now def perfect underscore numbers, and till n. So now let's just make a dictionary so it will be easier to see which number corresponds to which index. Okay, now let's just go in the loop, and I'm directly starting from 2 because we know if I is equal to 1, well, Mersenne index 1 is not a prime number, so it just reduces one calculation. It's just small optimizations. It won't even if you put 1, it won't make much of a difference, but I just like to reduce time as much as I can. So it goes from n plus 1, because if you go in the loop, in the for loop, it does not count the last number. So this range will now count from 2, 3 to n. It won't count n plus 1. And if you see over here, I wanted to return up until the Mersenne index n. Okay, so now it will check if the ith index is a Mersenne number, is a Mersenne prime, and if it is, well, there you have it. It'll put that in the dictionary, and it will return the corresponding perfect number, which we have already derived, which we've already figured out in my previous video. And well, now all you have to do is return this dictionary, and now we can see that if we print perfect numbers from, well, till 6. Oh, sorry, 1 minute, I think I might have made a mistake over here. So oh yeah, okay. I just realized I made a stupid mistake. I was supposed to print this. I put is prime by mistake for some reason. There you go. So now, well, 2 to the power, well, I've already shown the first 2 examples in my previous video, and for 2 to the power 5 minus 1, there you have it, 496. and you'll see how quickly it grows if I put 20. You can have a, well, 1 2 3 4 5 6 7 8 9, you have a 12-digit perfect number. How amazing is that? We have a, it's just so easy to find perfect numbers with this. Let me see if I can find till 50, or will it take time? Well, okay, till 30, so basically between 20 and 30 there are no perfect numbers. Well, you know what, I think this is something you should try on your own. It's a fun activity. You'll have a lot of fun doing it, and you know what, try coding this on your own. It'll be super fun. So, well, I guess that's it for the video. Hello again. Yeah, so that was me coding it in Python, and yes, I will definitely post the link of the GitHub. I will definitely post the GitHub link for this code. So, well, feel free to check it out. And yeah, that's it for the video. And yep, subscribe, I guess.